All right, let's look at an example of annually compounded interest and then look at some different compounding periods. So I'm going to use my formula that my amount of money is going to be the initial investment times 1 plus R. I'm going to write my R as its decimal form. And I'm going to have to pay that interest for 10 years, so it gets paid 10 times. So now I'm going to put this into my calculator. So we have 4,500 times 1 plus 0.0. Let's put in the point. Raised to the 10th because I have 10 years. And I want my money to be given as 2 decimals. So this rounding is okay. Just to come up and see my rounding though. So currently I'm at float 6. Let's go ahead and make that a little bit bigger to float 10. Okay, come up and do that again. So the bank is always going to make you pay more money. So the bank is always going to have you round up because we won't have a 2,000th of a cent. So the bank is going to round up and make you pay $8,150.52 back. So 8150.52 round up for the bank. All right, different compounding periods. Biannually means that we're compounding twice per year. Quarterly is 4 times a year. Monthly is 12 times per year. And daily, we're going to use as 365 times per year. So what this means is that our formula to become interest, so our balance, we can use balance or we can use, if we're going to use P twice up here, then my initial amount would be P sub 0 if you used P here. But if I'm using B for balance, then my initial principal is the amount I put in. Now though, I'm paying 100% of it back still, but my interest rate is still given annually, but I have to divide it by the number of times that my interest gets compounded. So I'm going to do R divided by my number of compounds per year. So if it's biannually, I would divide by 2. If it's quarterly, I divide by 4, etc. And now, if I think about my interest being compounded twice per year, that means in 1 year, this happens 2 times. So I'm going to take my number of years and multiply it by the number of times that it compounds to know how many compounds I've had over my time span. So here's the way that it changes. Notice if we just have annually, this is 1 and this is 1, and I'm back to my initial formula that we got up here. And again, if we wrote that with balance, we could write it this way. So if n was 1, I have a 1 times t, I have r divided by 1, and I just get that same formula. So you could always use this formula to determine different compounding rates. So let's see what happens here. So Holly has $15,000 in an account. So her principal amount is $15,000. Our interest rate is 4.25% per year, but she's compounding monthly, so her number of compounds is 12. Her time is 5 years, so, compounding monthly, 12. So over the 5 years, her interest gets compounded 60 times. So her balance is going to be the 15,000 times 1 plus my 0.0425 divided by 12 raised to the 12 times 5. And you don't need to simplify this any further, right? Just go straight to your calculator. 15,000 times 1 plus 0.0425 divide by 12 raised to the 12 times 5. And again, we're going to round up. Although if the bank is paying you out, they might want to round down. But we're going to round up and say $18,544.53. So if you were asked how much does she earn in 5 years, we would have to subtract out her initial amount of $15,000. And wow, that is a lot of money to earn over the 5 years. To earn over $3,000, you would be really lucky to get something paying this amount of interest. So let's look at that sort of idea. How much does Helena need to deposit into an account? So now we don't know her principal. She wants to collect $50,000 at the end of 3 years, and we've got an interest rate of 5.2%. Our compounds are quarterly, so 4 times a year. Our time is 3 years, and we want the balance to be $50,000. So she wants to take out $50,000. So that will include her principal. So it's not saying that she wants to earn $50,000. She just wants to take the $50,000 out. So $50,000 is equal to whatever that principal amount is, times 1 plus 0.052 divided by 4 to the 4 times 3 power. I'm going to use my solve function. Menu, I'm using my numbers, 3 then 1 to quickly get me there. We have 50,000 equals, x, let me use my variable, x times 1 plus 0.052 divided by 4 raised to the 3 times 4 is 12, and I'm going to solve for x. So the amount of money that she needs to invest, really we should just call this $42,821. Odds are you're not going to tell them, okay, here's my $42,820.99, but I would accept either answer. Odds are, though, she'll just give, really, you'd probably just give $42,800, but anyway, if she wants the $50,000, that's what she needs to put in.